Looks like we're all coming together here. How's everyone doing? Cut off there for a minute. Hey, Nick and Vince, can I get you to enable your video, please? Excellent, thank you. So before we get started, any questions on anything?
I guess I just sort of need to see the problems done a few more times because, like, I'm still trying to figure it out, I guess.
Yeah, chain rule and implicit differentiation are the hardest parts of this course, along with related rates. And if you understand those, you're pretty much set. You'll have things pretty easy. Okay. Yeah, Ryan. Okay, so let's go ahead and get started. We're gonna talk about some problems today, and we want to look at the problems without knowing the method to use to solve them, okay? So implicit differentiation and chain rule, we're gonna kind of combine. And part of the motivation for that is the fact that on the exam, and especially on the final, they're not gonna tell you how to do the problem. So what you wanna do when you're setting this up initially is you want to have a strategy. That's really the key thing. It's a lot like chess, where when you're playing chess, a good chess player can see several moves ahead. That's what you want to do with this problem. You want to understand what steps you're going to take, what rules you're going to use, without having to actually do them. Because when you get down to it, the only derivatives we know how to take are power functions, right? And power functions are pretty easy. So it isn't the power function that's going to give you trouble. It's understanding how to take the derivatives of various forms. That's what's going to give you trouble. So the first thing you always want to do is you want to figure out what is the form of the expression. So are you looking at a sum or a difference of functions? And when we're talking about form, we're talking about the last thing you're going to do. If you were computing this, what's the last thing you would do, okay? Do you have a number times a function? Do you have a function times a function? Do you have a function divided by a function? So here you're going to use the product rule. Here you use the quotient rule. Do you have a function of a function? Here you're going to use a chain rule. Or a special case of the chain rule. Do you have a function of y? And this is implicit differentiation. And so this is what you want to do. You want to ask yourself, what am I going to do first? And then you want to think about, after I do that, what's going to happen next? Okay, so let's look at this first problem. We'll go through a few practice problems that are like those in the homework. Okay, so what do I have here? What is my first form? Do I have a sum of functions, a difference, a multiple, a product, a quotient? Let's just go through them. Okay? I'm not adding or subtracting functions, right? That's not the last thing that I'm doing. I don't have a number times a function. I don't have a function times a function. I don't have a function divided by another function, but I do have a function of a function. So I'm going to use the chain rule. And so again, if we think about the chain rule, all right, the chain rule, we can do it kind of the old way, where we take the inner function, right? And the inner function is all that stuff that's pissing you off. It's the stuff that's making the problem hard. It's the inside function, right? So here it's going to be 6 times small x cubed minus 4 times small x. And then once I replace this inner function by the variable, I get the outside function, which is capital X to the 6. One of the ways that you've guessed correctly is you can take the derivative of each of these terms individually. So I can take the derivative of the inside function, right? That's relatively straightforward. So I'm going to take the derivative of this with respect to small x, and I'll just get what? I'll get 18x squared minus 4. And when I'm taking the derivative of the outside function, remember I replaced the inside function by a new variable. So here I'm going to take the derivative with respect to capital X now. And anticipating my next step, I'm going to put a parenthesis around this, because then this will be 6 times capital X to the 5th. And now I'm going to multiply these. So y prime is this derivative. So y prime is going to be equal to this whole derivative right here. So this will be, I can bring the 6 out in front and factor a 2 out of here, right? And I'll get a 12 times 9x squared minus 2 times. And my last step is I'm going to replace capital X now by small x. I'm going to substitute that back in. And that's my final answer. Having a way to set these problems up that's organized will really help you. It will help you both not make an error, and it will help you catch your errors when you're checking your work. Not to mention the fact that it will help me grade your paper, okay? And after you've done this a little bit, you're going to think about this in a slightly more adult way, right? You're going to think of this as y is equal to blob to the 6th. And then you're going to say y prime is the derivative of the blob, which will be 6 times blob to the 5th times the derivative of the blob. And that's really what we're doing here. Okay. Okay. Any questions that we have on this before we go on? Okay, good. All right, we look at this problem. What is the form? Ryan, what is my form here? Hello? Ryan?
Sorry, what's up? I was closing my door.
Okay, why don't I choose someone else then, because you probably didn't catch it. So, Jun, what is my form here? What is the thing I'm doing last?
What do you mean by form?
Okay, so what am I taking the derivative of? A product, a difference, a sum?
So for the 9x will be product, and for the 6 over x, there'll be implicit.
So not quite. So here's what I mean by form. What is the last thing I'm doing? The last thing I'm doing is I'm adding these, right?
Right.
So I'm going to have a sum.
Oh, okay. You mean okay? Yeah. So, yeah.
Okay. So I'm taking the derivative of 6 over x. Okay. Plus the derivative of 9 times x. All right. What am I going to do next? Again, looking down the road, I want to take the derivative of 6 over x. I don't have a rule for doing that. So what do I have to do?
Well, you're gonna have to get derivatives of two different, so that you can add them together.
Okay, right. So I'm going to take the derivative of these two terms. If I look at the first term now, how can I take the derivative of that? I don't have a rule for taking the derivative of 6 over x, right?
Right.
So how am I going to do that?
Isn't there like a formula to get the derivatives of fraction? I mean, like the.
We don't actually have one, right? So how do we take the derivative? Notice that 6 over x involves a reciprocal power of x, right? Reciprocal power means that you have 1 over x to a power, okay? How do we deal with reciprocal powers? What do we do?
You change that to 6 x2 minus 1.
Bingo, that's right. We bring him upstairs, and this is 6 times x to the minus 1. Okay. And now it's all product rule, right? I'm going to factor out my numbers. And the product rule tells me that I'm going to take the derivative of the first term by bringing the negative 1 down, and then reducing the exponent by 1, right? And the derivative of x to the first is just 1, right? And so the last step we have to do is I'm going to go ahead and combine these numbers, and now I'm going to go do the opposite. I'm going to take that negative exponent and put it on the bottom, right?
Right.
So this should look like this. That's my final answer. All right? Okay, good. Okay, so taking the same sort of approach, right? We want to map out our strategy. You know, this is like a war. You don't just go in aimlessly. You have a plan, right? So what am I going to do first? What do I have here first? A sum, a difference, product, quotient, what?
It's a difference, right? Because
so I'm going to take the difference first. That's right. When I'm taking the difference, what term is going to give me trouble here? There's one term that's not totally straightforward. Which one is that?
And then y to the fourth.
Right. And how am I going to do that? What form would the derivative of y to the fourth have? So here's the thing. Make a little list, okay? If you don't remember, that's perfectly fine. This isn't biology where we remember shit, right? And you know, we figure things out. This is mathematics. So I have a function of y, right? I'm going to use implicit differentiation. Okay, so this is what we mean when we talk about planning things out. Okay, so let's just go step by step. If I can get my page to hold still. There we go. Okay, so first we're going to do the difference. These problems generally aren't particularly difficult, but what will happen is people will try to rush, okay? They try to do too many steps at one time, and then they make stupid algebraic errors. Okay, so when I take the derivative of this, I know I'm going to have a number, and I'm going to use the power rule here. That's not hard. And so when I take the derivative of y to the fourth with respect to x, here's what you want to remember. So if we look at the rule for implicit differentiation, here's what it says. It says that if you take the derivative of a function of y with respect to x, first you pretend like you're taking the derivative with respect to y. Okay? But you're not. So the correction term is then you multiply by y prime. Okay? So I'm going to apply this here, right? My function, so if I look at this example right here, right? Hold still. So in my problem, f of y is y to the fourth. Okay? So I'm going to say that df dx, is equal to d dy of y to the fourth, right? That's my function, times y prime. Okay? And so this is easy. This is just the power rule. Right? It doesn't matter if you have x or y or s or t, right? As long as the variable you're taking the derivative with respect to is the same as the variable in the power function, we know the answer, right? So this is going to be 4 times y cubed times y prime. And of course, the derivative of a constant, right? The derivative of a constant function is going to be 0. So now we're done taking the derivative. What are we going to do next? What is our next step? What is the goal? What is it that we're trying to do here?
Getting y prime.
I want to solve for y prime. Exactly. So I'm going to bring all the y prime terms over to one side. Doesn't really matter which one. Which side you use. I'm just going to use this, okay? So now I have 32x cubed is equal to 28 u cubed y prime. Right? And of course, I cold-bloodedly did that because now I can just divide both sides by 28y cubed. And of course, it'll cancel on the left, on the right-hand side, right? And when I simplify, I can take out a common factor of 4. I'm going to end up getting y prime is equal to 8 over 7 times x over y cubed. Right? And that's my final answer, right? So questions on that? Anything you'd like explained?
For the answer, can we put it as 8x cubed over 7y cubed, or do we have to separate it?
Nope. And you may see it different ways. So either way is perfectly fine.
Oh, okay. Thank you.
Okay. At what point does the graph x squared plus y squared is equal to 24x have a horizontal tangent? I think I missed a problem. Hold on a second. I did. No, I didn't. Okay. I thought there was a problem before that. Okay, so there are a few phrases that should kind of stand out here. What does horizontal tangent mean? What are we trying to find? When we have a horizontal tangent, what do we know? So
That's like derivative of dy. I mean the slope.
Oh, exactly. So horizontal means, so you're absolutely right. Derivative of, well, and in this case, I'm going to use y, okay, because y is going to be my dependent variable. So y prime, oops, sorry about that. I don't know what happened there. Hold on a second. Okay. So y prime of x is going to be the slope of the tangent at x. So horizontal means what? Here's my point, right? Slope is equal to y prime of x. And a horizontal line has what slope?
0.
Sure. Right? So if we have a line that has a horizontal slope, it's going to be 0. Guys, can you please not have the background noise, okay? I really appreciate it. So horizontal tangent line means that we have a horizontal line, the slope is 0. So I'm going to want to solve for the value of x that makes the derivative equal to 0. So again, looking down the road, I know what I'm going to be doing. Okay, so let's go ahead and find the derivative now, right? So I'm going to take the derivative of both sides. And on this side, I'm going to have a sum, right? I'm adding two terms. So when I take the derivative here, I'm going to have the derivative of x squared and the derivative of y squared is equal to the derivative of 24x. Okay. And this prime, of course, means with respect to x, so this becomes 2x, right? And this is just 2y, right? Am I okay so far?
That would be times y prime.
Ah, that's right. Because this prime means with respect to x. Exactly. Very good. Okay. And of course, this term just becomes 24. Nothing to do there. And now again, I'm going to solve for y prime. That's the name of the game, right? So I'm going to bring my term over here. Okay. And I'll get 2y times y prime is equal to 24 minus 2x. And so y prime is equal to, I'm going to be able to cancel a 2 from both sides, okay? So I'm going to get 12 minus x over y. And so this gives me the slope of the tangent line for any value of x and y. Notice now it's a function of x and y, okay? It's not just a function of x. The reason why is because this is not a function, okay? This is a relationship. If you think about what this represents, it's a little hard to draw, but it essentially represents a circle. Okay, I won't go through and explain why that is, but this is essentially a circle. Okay, and notice a circle is going to fail the vertical line test. But notice what it means. It means that the derivative here, notice this is the tangent line at the same value of x. It doesn't just depend on x, right? Notice that for the same value of x, this tangent line and this tangent line do not have the same slopes. So this slope is a function of x and y when you have a relation and not a function. Okay? So not all graphs are functions. You guys know that. Right? And a circle is a classic example of that. Okay, so that's what's going on here. So now I want to solve for the value of x that makes the derivative equal to 0. So I'm going to set y prime of x equal to 0. And I'm going to solve for x and y. Okay? And so when I do that, I notice that I'm going to have 0 is equal to 12 minus x over y. So what are the solutions to that? What do you think? How do I solve that equation for x and y? Let me ask this a different way. If you have a fraction equal to 0, what do you know has to be true? What has to be 0? The numerator, right? Whenever you have a fraction equal to 0, the numerator has to be equal to 0. Okay? So we can solve for x. Now, we're not done because it asked us for the points, right? So I want the x and y coordinate. So the problem asks for the points. In other words, we need the x and y coordinates. How are we going to find y?
Just plug in 12 for the x.
Exactly, right. This point, wherever it is, has to lie on this curve, right? So if I know where x equal to, if I know that at whatever point I'm interested in the curve x is equal to 12, I'm going to have a quadratic in y, right? So I'm going to go ahead, I'm going to substitute. Move this down a little bit. Come on. There we go. So I'm going to go ahead, I'm going to substitute x equal to 12 into my original equation and solve for y. And that's easy to do because they give you nice numbers. So my original equation was x squared plus y squared is equal to 24x. So when I plug in for 12, I'm going to get 12 squared plus y squared is equal to 24 times 12. And when you go through the arithmetic, you get y squared is equal to 12. And I'm going to have two solutions, right? This is a solution to a quadratic. So this tells me that y is equal to plus or minus root 12. So my solutions are 2 and plus square root of 12 and 2 and minus square root of 12, right? Now that's a problem that you could see on an exam. That's a perfectly legitimate exam problem. That's a good problem to practice. Any questions on that or things that we'd like to see worked over? Okay? All right, good. Okay, let's look at the next problem then. So I want to take the derivative of this. Again, I want to kind of map out my strategy, right? What sort of function do I have here? What am I going to use? What is my form? So here I'm going to have a function of a function. My inside function, and the way that you detect it is the inside function is the thing that pisses you off, right? Say, man, I could take the derivative of the cubed root of x, but I don't have the cubed root of x. I have this big honking mess right here. That's going to be your inside function. So we know that we're going to use the chain rule. So let's go ahead and use the chain rule. So my inside function, capital X, is just going to be x cubed minus 6x. And my outside function, which is going to be f of the inside function, is just capital X cubed root of. And I can check myself. If you're on the exam and you say, man, I don't know, is that really a chain rule? The two ways that you check yourself is, first of all, put the inside function into the outside function, and you should get back the original function. And the other thing is you have to be able to take the derivative of each of these quantities, and you can. So you know you're on the right track. You have these kind of checks for self-consistency, you might say. And now we're going to go ahead and start to take our derivatives. So go ahead and take the derivative of those two. I want you to do it, and let's see what you get. See if you're getting the same thing that I get. I mean, you want to check me. I'm starting to get kind of old. Who knows, right? I might be making mistakes here. So this first term, I'm going to take the derivative with respect to small x. And I should get 3x squared minus 6. Now, to take the derivative of the outside function, what do I have to do? I don't have a rule for taking the derivative of roots, right? So what do I have to do before I take the derivative?
You have to convert it to a fractional exponent.
Sure do. And now I'm sitting on ready to take the derivative with respect to capital X. Okay? And again, that'll be 1/3 capital X to the positive 2/3 power, right? Does that look okay? I made a mistake.
It should be negative 2/3.
Good, good. Checking you guys. I can't fool you at all. And so I'm going to multiply them next. Okay. And then I'll go back. I'll make this a positive exponent by bringing it down, make it a root, put in for capital X. So let's go ahead and do that. So we know now that y prime is the derivative of the right-hand side, which is going to be 3x squared minus 6 over 3. And I'm going to bring the x downstairs and make the exponent positive now. And of course, my last step will be to substitute in for the inside function. All over top of . Okay. How's that look? Now, one of the things to be aware of on the exam, you might not see it like this. What if they wrote the answer as a root? What would this look like if they used the root? Remember, fractional exponents that aren't whole numbers, right, can always be expressed as roots. How would I write this as a root? Well, let's use the fact, we have this little fact that we learned before, right? It says x to the m over n is equal to the nth root of x to the m. Remember that? And so I can employ that, right? So the denominator is always the index of the root. So that's going to be 3. And this will be the square root of. And then this is going to be the power of the radicand, right? X cubed minus 6 squared. And so you want to be aware of that, right? You know, with verify, who knows what you're going to see, all right? So you might not see it as a fractional exponent. You might see it as a root. So you have to be careful. So does that look okay? Anything else that we want to discuss there? All right, good. So if we look at the next problem, let's kind of break this down. So first it's going to be a sum and difference, right? This term is going to be a product. And inside of the product is going to be implicit differentiation. And this term is going to be implicit differentiation. So this is what I'm referring to when I'm saying you want to look down the road. You want to have a strategy. First, you're going to take the derivative of each term. This term is first going to be a product. And in the course of doing the product, you're going to have to use implicit differentiation. And that term is going to be implicit differentiation. And if you can see that, you know how to do the problem. You don't have to even work it. So let's go ahead and go into the details though. So first I'm going to take the derivative of each term. Okay. Derivative of the first term is going to give me what? This is a hard one. You know why it's hard? Because it's so easy. That's why it's hard.
It should be a times y prime.
Exactly. Some people sit there, they go, what is it? It's just y prime. It's just dy dx, right? So there's nothing hard about it. Good. It's just 8y prime. Of course, this is minus 7 plus. Having a bookkeeping method is good. So I'm going to take out the 6, and I'm going to anticipate the fact that I'm going to use the product rule now. So first I'm going to take the derivative of the first factor times y to the 4th plus x cubed times the derivative of the other factor. Okay. And of course, here this first term on the right-hand side is 0, and I'm going to have the derivative of y to the 4th on the right-hand side only. And now I see that all I have is the power rule and implicit differentiation, and that's it. So let's go ahead and do that. I'm going to have 8y prime minus 7 plus 6 times, and this first term will be 3x squared times y to the 4th plus x cubed times, and we've done this one already, right? Y to the 4th apparently turns up a lot today. This is implicit differentiation, right? And this will be 4y cubed, taking the derivative first with respect to y, and then multiplying it with respect to y prime. And this last term is essentially the same, right? Except there's a negative sign. So 4y cubed times y prime. So now we're going to solve for y prime. We have a y prime term here, and a y prime term here, and a y prime term here, but this y prime term is inside of a cage, right? I'm going to have to multiply through by 6 to let him go free. So let's go ahead and work through the algebra here. So I'll just jump down here. And you can go ahead and get started on that while I'm moving this stuff around. So we'll get 8y prime minus 7 plus, distribute the 6, right? 18 x squared y to the 4th. And I have a 6 times 4 here, plus 24 x cubed y cubed y prime is equal to minus 4 y cubed y prime. I'm going to put all the y prime terms on one side. It doesn't matter which side you put it on. Most people prefer to put it on the left-hand side because you're going to solve for y prime anyhow. So that's what I'm going to do. So again, just as a form of bookkeeping, so I can go back and check myself later on when I'm finished. These are all my y prime terms. So I'm going to bring this guy over here and bring these guys that are non-y prime over to the other side. So we have 8y prime plus 24 x cubed y cubed y prime plus 4 y cubed y prime. And now when I bring this one over, he'll become positive 7, right? And this will have a negative sign on it. Okay. All right, what is my next move? What am I going to do next? How can I get y prime? Here's what you want to notice. Every term here has a factor of y prime, right? This is 8 times y prime. This is 24x cubed times y cubed times y prime. 4y cubed times y prime. So what can I do algebraically here? Begins with an F. Factor. Right? So let's go ahead and factor. So when we do that, pen stopped here for a second. There we go. Okay. When I take the y prime out of the first term, I just have an 8, right? When I take it out of this term, I'm going to have 24x cubed y cubed. And I take it out of the last term, I'll have 4y cubed. See, I cold-bloodedly set that up, right? Times y prime. And on this side, of course, nothing happens. But I'm going to divide both sides, right, by this quantity. And here, of course, again, cold-bloodedly set that up, right? So it'll cancel. And I'll have it, whatever I do to one side, I have to do to another when I have an equation, right? And plus 4y cubed. Okay? And now we just write our final answer. Our final answer will be y prime is equal to 7 times 18 x squared y to the 4th all over top of 8 plus 24 x cubed y cubed plus 4 y cubed. And that's my final answer. You really have to be careful with the bookkeeping because there's no way anybody, myself included, can look at this answer and know if it's right or wrong. And that's one of the reasons why taking your time and doing your work out neatly, okay, even though it's a little on the long side, I can go back and check myself each step to make sure I didn't make a mistake because it's very easy to do. When I'm checking your work, it will make it really easy. If you go like straight to the last step, okay, but you're wrong, I can't give you any partial credit. You just get a 0, right? Because I have nothing to grade in between. So when in doubt, write it out. Okay. Any questions that we have about that? Good? Okay. Let's see. Okay, let's look at this problem. Y is equal to 4x cubed times a quantity 7 minus 3x squared raised to the 6th power. So what are we doing first? First it's a what?
Is it a product first?
Exactly. Okay. So it's a product first. It's a product of this times this. Within the product, what's going to be the hard part? What am I going to have to do inside of the product for one of the terms?
There's going to be a difference inside of...
But
and you also...
So I'm going to have to take
the exponent outside of it.
Right, so I'm going to take the derivative of this and the derivative of this, right? And that's easy, but what am I going to have to do to take the derivative of the second factor? Okay, whenever you have a function raised to a power, it's always going to be the chain rule, right? So we're going to use the product, and then inside of the product, we have to use the chain rule. Okay, let's go ahead and try that. So, you know, it's kind of like Zen, you know, you know how to solve the problem without having to solve the problem, okay? All right, so take the derivative of both sides, okay? I'm going to have the derivative of 4x cubed, and of course I leave that guy alone, plus 4x cubed times the derivative of this. Whoops. Raised to the 6th, derivative of, okay? Now, when you're doing a problem like this, okay, the first term's not going to pose any problem, but the second one's going to be a little involved. It's not a bad idea when you have something that really is kind of cumbersome and tedious and kind of long to do it off to the side. Okay, so I'm going to do the one derivative off to the side, all right? So I'm going to do the easy derivative, right? So I know that y prime is equal to, and I can do this one directly. So that's just going to be 12x squared, right? And then this will be 7 minus 3x squared to the 6th plus 4x cubed. Okay, who wants to kind of take a guess? How can we do the derivative of this using the chain rule? What are we going to get? This is the blob, right? So what is the derivative of blob to the 6th? So the derivative of blob to the 6th with respect to blob is what? Six blob to the 5th, right? And this is eventually what you want to get to. You want to start thinking in this way. I mean, you don't have to use the word blob. It's just kind of funny, okay? But at the end of the day, that's how you want to start doing the chain rule, okay, rather than use a table. And then, of course, I'm going to have the derivative of the inside, which is just minus 6x. Okay? And now we go through, do a little bit of algebra, and we're home free. Do not expand these out, okay? This is going to be a real mess. Just leave these, whenever you start having quantities raised to powers, just leave them alone, okay? It's going to get to be a real mess if you try to expand it out. 7 minus 3x squared to the 6. And I'm going to combine these two factors right here, right? And I'll get minus 24 x to the 4th. Oh, I have another 6 in there also, right? So, hold on. I have 144 actually, sorry. I missed a factor here. This is actually 144. Because I have a 6, 6, and a 4. Ah, oh, come on. There we go. Okay. X to the 4th times 7 minus 3x squared to the 5th. And if I wanted to, I could take out common factors, right? I have a common factor of x cubed. I have a common factor of this quantity to the 5th power, but that's okay. However, on the exam, you might see that. So you might want to practice factoring this out and simplifying it, because actually it will simplify a little further if you do that. Okay, time bell is up, so I'll go ahead and post this video later. And if you have any questions, feel free to ask. I'll be available this weekend, okay?
Professor, I just have a question about this week's homework. I noticed that there's 2 different types for chain rule homework. I don't know if we have to do both or just follow what's on the module.
Let me see. Let's see really quick.
There's one that says derivatives and then dash chain rule homework, and then there's one that just says chain rule homework.
Okay, let's see. So again, always want to follow modules. Don't.
Okay, so just follow the module because that's under assignments. I saw that there were 2. So it's not under the module. So I just wanted to make sure if we just follow the module or.
You'll be home free as long as you do that. You'll be fine.
Okay, just want to make sure it doesn't affect anything.
No problem at all. I appreciate you checking.
Okay.
All right.
Thank you.
Have a great weekend, guys. Take care.
Thank you.
Bye.
Okay, thanks.